Guys, how you getting on there? Guys, before Christmas there was a couple of weeks there where people didn't really get a chance to uh, come to class because of, say, deadlines been due and teaching practice, thesis, and so on and so forth. So I wanted to just finish off by looking at one or two things that we didn't get a chance to really look over, and we won't get a chance to be able to go back onto when it comes to our hyperbolic parabolas. The two things we want to look at are just one is extending on the hyperbolic parabola onto a boundary surface, and then the second thing is how to find the plane generator um, for the hyperbolic parabola. So um, if we look at say this question here, we're going to first of all look at how to extend on our surface, and we'll do a separate video on the plane director and really try to explain what's going on there. So the figure shows a hyperbolic paraboloid canopy roof. The canopy is based on extending the hyperbolic surfaces A, B, C, D to the edge of the circle and plan. So we have A, B, C, D, A, B, C, and D, and that's our original, the four sides of our hyperbolic parabola. And you can see we have this boundary circle here, and which we extend on our surface. So if you can imagine, just extending on our surface until it meets this boundary surface. The question is set up here. I'm not going to worry too much about the setup of the question. Basically, we have all the information that we'd need. We'd be able to draw on this guy here. We know that the coming out 20. So you draw in your circle. You're able to draw in this line. Then you're able to come up here to locate this line here and join up the two of them. So let's just have a quick look at it. So there's the coordinates given to us for the elevation. There's our roof surface drawn in, just using the measurements that were given. So basically, it's no different to any other question at the moment. We just worry about the four sides of our hyperbolic parabola, and we divide them up into a number of equal parts. So 1, 2, 3, 4, 5 there, using our division of lines method. We do the same with the sides, so division of lines method, 1, 2, 3, 4, 5, for argument's sake. And again, the more lines you take, the more accurate it's going to be. But if you remember from before, if the question maybe showed that you had a cutting line cutting across maybe the sixth element, well, you want to make sure you have 6 elements. So in this case, it won't particularly matter. Okay, so that's our hyperbolic parabola here. We're going to project that up into elevation, and we're going to find our lines in our elevation. Now, I've just done this very, very quickly, this animation, so I haven't labelled it up, and I hope I don't need to tell you that, definitely labelling it up makes life an awful lot easier for you. So basically, the idea is that once we have our generators like so, we just simply extend them on until it meets the boundary. In this case, our boundary is in our plan view, so we extend them on. So if we call this is line number 0, there's number 1, number 2, 3, 4. And when it hits the boundary, well, that's how far our extension finishes. So once we have our extension here, we can bring it up and continue on the same point, or the same line, like so. So that's where our extension is in elevation. There it is, like so. There it is, like so. Like so. And then we do the same for our generators moving in the opposite direction. Bring her up, continue them on. And the same 1, 2, 3, 4, 5. Same with the sides here. Same with all the base ones. Like so. And then it's just a simply case of just join the dots. So there is our boundary surface now in elevation. And that's really the crux of the question. It's exactly the same if we had, say, our circle inside our piece here, like that. If we had our circle inside our piece, we would just cutting each of our generators short, so wherever it crosses the generator, you'd bring it up, and that's where it would be in elevation. So it's quite a common question that appears. I think actually the most common example of it is your Pringle shape, and that actually came up in DCG Leaving Cert 1 year. So again, your Pringle was just an ellipse shape, and you're extending your hyperbolic parabola onto the ellipse boundary. So that's how to extend on our surface like that. As far as the plane director goes, I'm going to create a separate video for that. So I'll make up that, and I'll post that up onto Moodle as well. So okay, best of luck.